Okay, here's problem number 5. This is a calculator problem, so I got my calculator handy. I can already tell what my window is going to be, so I'm actually going to set that up first. So my x is going from 0 up to 25, but I like to go a little farther to the left of it, so I'm going to put in like -5 up to positive 30. Let's put in 30. And then for my y, it's going, I'm going to do the same thing, -5 up to positive 30, because I like to have a little buffer around the edge there. So there's my graph. I have it set up so it's similar to this window. Okay, now I'm going to go put in my equation. I have 15 times the square root of x minus 3x. Okay, in this case it's t. And I'm graphing it between 0 and 25. Okay, so let's graph it, see what it looks like. There it is. So notice it tells me when I graph it, I need to make sure I show where the maximum point is. Okay, we also want to show our endpoints. We want to show what happens when t is 0 and when t is 25. So we're going to use the value function on our calculator to help find that. So second, calculate value. I want to know where is it when x is 0, and it's at 0. So it's starting at 0, 0. And I want to know what's its other x-intercept over here. That is when, well, I mean the end anyway. I want to find out where that is. But I'm first going to find out, well, what is the t-value at 25? Okay, so let's put that in. Value when t is 25. Oh, would you look at that? That actually happens to be the x-intercept. How convenient. So we're going from x-intercept to x-intercept. Now I need to find the maximum. I can do that on my calculator as well. So I need to make sure I get to the left of that max. So moving my cursor over and to the left of it, it looks like. Now go to the right of it. That looks like I'm to the right of it. Enter, enter, enter. And it gives me the maximum at 6.25, so about 6 1/4, and 18.75. And I'm going to want to label that. So 5, 6, 7, 8, 9. Yeah, this is 6 1/4 and up to 18.75. So 6 1/4, 19, 18.75, around there. That's going to be my maximum. So that's going to be at 6.25, comma 18.75. Notice I put all the digits in for that one because I think that was an exact answer. 18.7 left 5. That looks like an exact answer. I didn't really have to round it. All right, so I'm going to put this in. Curves. Okay, and that should be the maximum. I kind of muffed that a little bit, but you get the idea. Okay, write down an expression for distance. D is distance, the distance traveled. So when we do the distance traveled, we can integrate. This is my velocity function. So I'm going to integrate my velocity function, and it would be the absolute value of this, but notice the whole thing is above the x-axis, so we don't have to worry about using the absolute value because the whole thing is above the x-axis anyway. So if it makes you feel better, you can say, oh, that's the absolute value of v of t. Okay, you could do that. And it's from first 9 seconds, so it would be from 0 to 9. But since the entire function from 0 to 9 is above the x-intercept x-axis, I don't have to worry about the absolute value. But if you wanted to practice with absolute value, go for it. Okay, so this is the same thing as from 0 to 9 of our function. V of t is 15 square root of t minus 3t, comma dt. So that's an expression for d. D equals, I can write it like this, but since I know what v of t is, I'm going to go ahead and put it in. I didn't bother putting the absolute value bars because the whole thing is above the x-axis anyway. Okay, hence write down the value of d. So that means I'm going to use my calculator. Yay! So this is a real easy calculator problem. So I already have it in there, so now I'm going to go to 7. My lower limit is 0. My upper limit is 9. I'm just going to shade it in. Here it comes. And it's going to tell me my answer of 148.5. So if we're rounding that off to 3 significant figures, it would be 149. And it's a distance, so I'm not going to put units squared because I was given a velocity function. I'm trying to find distance, so it's actually going to be 149 meters, not meters squared, because we're actually talking about a distance. We integrated the velocity function to find a total distance. Okay, just for laughs, I want to show you that I could have gotten that same answer using absolute value, so I'm going to clear that out. I'm going to show you what we did in class, math, number, absolute value, and then plug in my 15 square root of x minus 3, oops, let's try that again. 15 absolute value of x minus 3x, okay, and that's all in my absolute value. Notice if I graph it, notice, oh, I do get the exact same thing, okay? Oh, except over here, past the 25, that's where it gets funky, but we don't need that. And then if I do my integration from 0 to 9, you'll see we get the same answer, 149. Let's do better. And there it is, 148.5, or 149. All right? Oh, that was an easy one.